Hello and welcome to the second video in the series Educational Videos for Novice Java Programmers. Today I'd like to focus on syntax errors. I plan to show you 4 common syntax errors that are experienced by novice Java programmers, why they occur, and how to fix them. It should be noted that all of the errors that have been chosen for this video, and in fact all of the videos in this series, have been taken from different pieces of literature on the subject. Deepak and myself have compiled together a wide variety of resources, looking at all of the challenges and misunderstandings faced by novice Java programmers. Firstly, I'm going to talk about some of the possible confusion between the assignment operator and the comparison operator, when you should use each one, and what consequences may happen when using them incorrectly. Then I will show you 3 common syntax errors related specifically to methods, such as missing brackets, incorrect parameter types, and also including type in parameter calls. So now let's move over to IntelliJ to have a look at the first one. So now to look at the first error that I wanted to talk about today, which was the misunderstanding that students have between the assignment operator and the comparison operator. So to define the assignment operator first, essentially what it means is that it will assign any value on the right-hand side of the assignment operator to the value on the left. So when looking at primitive types here, so primitive types being int, double, byte, boolean, char, etc., we can simply assign any piece of data as long as it is the same type on the left-hand side to that variable. So what this line really means is, in memory, create enough space for an int, call it temp number, and assign number 2 to that variable. So if I'll comment those and run that, we can see it simply prints out 2, 1.2, and 1, because these variables are holding these pieces of data here because they've been assigned to them. One important thing to know about primitive types and variables is that they have to be assigned. So as you can see here, this variable has never been assigned, and therefore because it hasn't been initialized, we can't use this, obviously, because it hasn't been given something for it to hold. That is why we have to give it some data here. So with primitive types, that's fairly simple. Both things on side of the assignment operator have to be of the same type, and then this assigns to this. Whereas looking at object types, some things are fairly similar, but some things are also a little bit different. So string, which you should know, string is in fact an object type, and we have here a student and a module. And as with primitive types, these also have to be initialized, and these have never been assigned any data. But one interesting thing that you can do with object types is what's called null initialization. So what that means is, because this object, we can refer to it as being null. So it means there is nothing there, but it is still initialized, it's just not initialized to anything. And it should be seen that that primitive types can't be null initialized. As you can see here, you have to give it a piece of data. Whereas an object, you don't necessarily have to give it data at first, but it does have to be initialized in some way. So what it's obviously looking for is a string, which is the same type as here, and student. So obviously the value on the right also needs to be a student. So one way that we can get a student in this case is by getting a student from the controller class. So using ID1, this statement will return a student, and therefore assigning this return student locally here. Therefore we can then use this temp student variable to do any functions on that. And the same for this one, where we can call the get module as such. So now if we print that, we'll see down here that it's printed string, the student, and the module. One side note that should be taken into account here is, if you notice, these are objects here. But what's been printed down here is in fact strings. So what these objects have done is actually call the toString method from that object. So you can see here it's printed the ID, the full name, date of birth, and the modules that have been taken here. So without us even asking, it has automatically done that behind the scenes so that it can print the strings down here. It would essentially be the same as calling the toString method on the object, but we don't need to actually write that. It's done it for us. So therefore we can see that primitive types have to be the same on both sides of the assignment operator, and so do object types. But you can be a little bit clever with this, where here we've created a new student. We've returned the student here and assigned it to this variable. And now we want to extract some of the primitive data from this object. So we're going to create a new local primitive type int called student ID, and then we are going to call the getID method on that student. And then what this will return a int, and then we can store that locally. So not only can we return objects, we can return primitive types and then store them locally. And I would recommend always storing primitive data and objects locally. Obviously here, when you're just printing them out, we don't necessarily have to. You can simply just call this, because this statement will return a student and it will be printed out. But it is always better to capture the object and store it locally, and then you can perform multiple actions on that object. So now we can look at the comparison operator. What the comparison operator means is it tests for equality, and it will return either true or false depending on if the two variables or any two things are identical. So looking at primitive types here, we've got two more primitive types. These are both ints, and they are both assigned the number 5. So you can see they are both identical. So if we are going to test for equality. So in this if statement here, this statement needs to be true in order for this block to be executed. And if we run this, we can see that it will print true 1, because essentially what this is saying is, if true, print this. And obviously first int equals second int is in fact true. Whereas if you were to use the assignment operator in this context, you would get an error saying it requires a boolean, true or false, but has in fact found an int, because this is assigning a number to a variable. This is not a test for equality. This is not a returning anything. This is moving data, not testing data. So that is why you can't use the assignment operator in that context. But obviously here you can use it outside of an if statement or a conditional statement and just create a new third int where you can pass it a number 5, because second int is obviously a placeholder for number 5. So that does work, but obviously it can't be placed inside this if statement, because here it's looking for a test of equality. So for primitive types, that's fairly simple. But with object types, things can also get a little bit tricky. So here we have two students. student S1 and student S2. And we are assigning them identical students here. So you can see they're both looking for the same student, but just assigned to different objects. If we do this test of equality, it prints out true 3. Because what it's doing, although these are objects, it's actually looking through each piece of primitive data inside that object and comparing them. So it's looking at both of their names, both of their last names, both of their courses, etc., testing each individual primitive type. And then if this equates to true, which it does because they're identical students, it prints this out. So when you're looking at object types, you can test them together, but there are some cases where it doesn't actually apply. So if you look here, we have 2 strings, S1 to string and S2 to string. And we are going to call the toString method on both of these objects. And as you just saw, both of these objects are identical. They contain the exact same information. But if I'm assigning their contents to a string, and if I go to test these now, you'll see it's not as expected. It doesn't print true 3. Although we've just seen that these 2 objects are identical, all of their contents are identical, and we're assigning 2 strings from identical objects. So why doesn't this print true? This comparison of 2 strings does not equal true. That is because when you're comparing 2 strings, it is in fact comparing their references in memory, not their literal contents. Although you may have 2 objects that are in fact equal in value, because they are stored in 2 separate locations in memory, they aren't in fact identical. So if you were to look at this and this in the eyes of this if statement, there would be a memory address, not the toString method here that you would expect them to be. And we will see later on how to test for equality for 2 strings properly. So that is the differences between the assignment operator and the comparison operator. So now that we've looked at that, we can move on to the next one. So now it's time to move on to the second part of this video, where I want to look at syntax errors that are related just to methods. Specifically missing brackets, incorrect parameter types, and including types in parameter calls. So the first one, missing brackets, is a common error that people don't understand the difference between methods and fields when accessing objects. So we've seen this line before where we are calling a method on this controller object here. So, and you can tell that this is a method because of these brackets at the end. That is how we know that this is a method. But we don't always have to just call a method on an object. We can instead simply look at a field instead. So if you use the full stop at the end of an object, it gives you a list of everything that you can access from that object. And in this case, we're trying to find the, the department of this staff member. We can simply access that field here. The reason we can do this is because in the staff class here, the field department is public. When you don't define whether it's private or public, by default in Java, it will be public. Therefore, we can just simply access whatever this string will be. But this is known as bad practice in Java. You shouldn't do it like this. by allowing people, or by allowing your program to access a field in a class, this allows people to look at the underlying structure of your class, which is not a good thing. Instead, your fields should be made private and then accessed with a public method instead. So here we have the public method that will return a string called getDepartment. We can tell this is a method because of the brackets at the end, and instead this will return the department. So instead of simply accessing a field, we should only ever use methods to access data on an object. This is a much safer way to do things in Java. So as you can see here again, you can tell this is a method because of those brackets at the end. So also you'll notice the difference between these two is that these brackets are empty, whereas this one has a 1 inside it. And this 1 is referred to as a parameter. And a parameter is something that a method can require in order for it to carry out its functionality. So as you've seen down here, if we do controller.getStudent is the one we want to return a student here, we can tell that this is a method, which is what we want to use. And you can see here in these brackets that there's an int ID. And this is saying that it will require an integer in order for it to be able to be used. So if I place that in there, again, you can see it's raised an error saying that it requires an int in here. So when calling a method, all you have to do is simply provide the data that it requires. So all you have to type is just an int, and that is it. That's as simple as that. So you can see here that it has this little grayed out ID here. Now I didn't type that, but IntelliJ quite cleverly has placed that there to show me that this number 2 will be referred to as an ID. Now if we go and look into the controller class at the getStudent method, you can see here this is the definition for what parameters this method requires. So it requires an int, and it will refer to this int in the scope of this method as ID. So that is when you just have one parameter. But what if you have multiple parameters? A good way to demonstrate that would actually be to create a new student. So as you can see here, it actually requires 7 parameters. So it requires 3 strings, 3 ints, and 1 more string here. So remember I said before, when calling a method, you simply have to give it the data that it requires. So you're just going to place here a string like so, and to separate out parameters that you're giving it, you use a comma. You can see this bold text has moved on to the second thing that it wants, which again is another string. You can use spaces as much as you want to make things clearer, but you can only use a comma to separate out parameters when calling a method. So we will just continue to add in some things here like that. And this is a really good way also to demonstrate the importance of defining what parameter names are in your method and how appropriate they need to be to make your code more readable. So if we go to the person class here, because the student inherits its constructor from this person class here, you can see here this is where the parameters are defined in order to create a new student or staff member. So we have first name, middle name, last name, etc. And if we were just to call these name 1, name 2, name 3, for example, that is not particularly good practice, because in this case, you wouldn't know whether the first name needs to come first, or it could be last name first, for example. If it's like a register, often the last name comes first. So that's why here it's important to name parameter variables carefully. So therefore it's more readable for you and other people looking at your code. So that way you can always be sure to enter the correct parameters and not the incorrect parameters. So lastly, one thing that some novices tend to get confused by is including the type in a parameter call. So a good way of explaining this, I've simply defined a local method down here called getAllFirstNames. This will return a string of the first names of the students that it's given based on their ID. So in a method definition, you can see here I've said that it requires an int twice, and these ints will be referred to as this and this. And these can be anything, of course. You can have any type in here as long as the information that is given to this method is the same as the types that you've defined here. So as you're defining the method, you have to say what type of information it requires. But when you're calling the method, when you're simply using the method elsewhere, all you have to do is give it the actual information that it requires. So in this case, an int, you simply type in the number that you want it to use, comma 2. There are the 2 ints that it requires. You notice how I didn't type int 1, int 2. That is not what we're looking for here. You'll get all sorts of errors when you include the type into this parameter call. So the most important thing to take away here is that you should always define your methods by including the type, and call the method by just giving it the data itself. So they're the 3 things I wanted to show you about methods. So in this video so far we've had a look at the differences between the assignment operator and the comparison operator, when you should use one over the other, and then these 3 errors that we just looked at to do with methods. So in the next video we will be having a look at some more syntax errors, but until then, thank you very much for watching.